Welcome back, everybody. Let's talk about the auxiliary view, chapter 8 today. And let's give you a brief introduction to auxiliary view. Auxiliary views are developed from a line of sight that is perpendicular to the inclined surface as view looking directly at the inclined surface. Purpose of the auxiliary view is we can illustrate the true size of surface, illustrate true shape of the surface, including all true angles and or arcs used to project and complete other view. And if you look at the front view auxiliary view, an auxiliary view can be constructed from any of the regular view. As you can see from the top view here, we have inclined surface here from the front view, and you're going to project them to the top view and the side view. This is another example of top view auxiliary view, and this is the top auxiliary view. This is the front auxiliary view. When you project them from your front view, you call it front auxiliary view. When you project them from your top view, you can call it top auxiliary view. When you project them from the side view, you call it side auxiliary view. Drawing auxiliary view, we're going to go through the step how we're going to draw the auxiliary view. Step 1, we're going to label all the important points of the auxiliary view. So we would label all the point A, B, C, D, and this point here is A, B, and C, D. And on the side view, you do the same thing. You label them A, B, C, D. So what are you looking at? Notice that the inclined surface, because the inclined surface is on the front view, this will be the front auxiliary view. You're looking at the front view. And the next step we're going to do is to construct a reference line in the adjacent view. This line should pass through as many points as possible. So you're going to pass through, first you're going to label all this reference line, and this reference line here has to be parallel with this reference line, and all this reference line we can call it a fold line. So T is a top view, front view, and then this is your side view. So we have two ways to do it. The first way is to construct all the reference line in the adjacent view, or if you prefer not to, this is another way that you don't want to make so many reference line by simply using this line as your reference line. And then once you have all this reference line drawn, and draw up a projection line 90 degrees from the inclined surface, and then construct another reference line parallel to the inclined surface. So when you start looking at this, you have all this reference line drawn, and this you're going to draw a projection line 90 degrees from the inclined surface. So from the inclined surface, draw one perpendicular to the inclined surface 90 degrees. Same thing, draw another 90 degrees, and construct another reference line parallel to the inclined surface. So this is your inclined surface. Draw another parallel that is to the inclined surface. Then you already have your point label. So then you have all these distances. This distance A, B, and distance B, C, from here BC is the same as C here. The reason why you're going to project them AB, you project them to AB, and then project them horizontally AB. So your distance here, AB, is equal to AB respectively. Same thing to CD, and your CD you project all the way down and project this way, and your distance CD is also equal to CD. And now that you have all this ABCD, you have now you already have this 90 degrees incline projection line, and then you're going to do the same thing. This is your reference line, and your A, from here you project them perpendicular to the inclined surface. So your A now is going to be distance here, distance A equal to the distance A, distance B equal to that distance B. Same thing to CD. So you're gonna measure C is equal to C, D equal to D. One thing you have to notice that you always skip a view to get the distances. This is another method of instead of having this reference line, you can draw one reference line, and then this is your reference line, this is your reference line. So the same thing, you project them here, project them out. So your distance is gonna measure from here. So your D, because your D is at 0 distance, so that will be a distance D. A, project here, then you get distance A. Same thing B, project here, go up here. So your distance here is equal to the distance here. Now that you have all this line, you already project this line, and then once you have B, C drawn, and now you can just measure the distance from the reference line to the view and transfer this to the inclined surface line. And then recheck all your work, especially the reference line, transfer distances, and projection angles. So now that this is your auxiliary view, true shape, true size. Once you finish it, you're going to darken this line, and that will be your auxiliary view. This is an example that drawn only the inclined surface in the auxiliary view. You don't need to draw. This is the main thing that you want to draw, the inclined surface. This is your true length. And you don't need to draw this because this is not your inclined surface. And because this is not your true size, true shape, so this foreshorten, not true length, you should omit it. Okay, I'm gonna end the video 1 here. We're gonna continue with video 2 with a round surface.